we've done the seedlings. Let's move on to adult plants. And basically, again, it'll be applicable to all the three rusts of wheat: stem rust, yellow rust, and leaf rust. And I'll concentrate on the practical scoring at the end, but just to start us off with, I will just state what the research objectives may be, and then something about field trials and the layout, management, etc. Those of you that work in the field regularly will know this. Then we will get on to the rating of adult plants, the scoring systems. I also have an exercise or an example, how to calculate the area under disease progress curve using Excel, if you would like to have that information. And then adult plants can also be quite effectively be evaluated in the greenhouse if you have a good system. And then we will move on to the, basically it's just a stem rust scoring exercise. So when you work with these pathogens and diseases, there are several questions you can ask. And the first one probably would be, are my cultivars or other germplasm sources resistant or susceptible? And then you have to expose your breeding material to the appropriate panel of pathogen races or pathotypes, especially for detecting APR. And I think we increasingly being made aware of the fact that APR could be more durable and that we should concentrate on combining several APR QTL regions into single varieties. We may also want to know what is the effect of rust on yield, and then have sprayed versus non-sprayed treatments. That's got to be done in the field. We can also phenotype mapping populations in the field to determine the genetic basis, how many genes are involved, where are the genes or QTL located in mapping exercises, and then also maybe something like trap plots, simply exposing certain genotypes, host genotypes to the prevailing races in your region. And then the outcomes would be, I won't go through all of these individually, but I think there's a host of outcomes and very valuable outcomes for the rust community in terms of what we can determine and the data that can be obtained from good field work, good adult plant work. So first of all, if you want to do rust work in the field, the choice of the site is extremely important. You can't do it in an environment that's not really conducive for rust development. Plot size and layout, that depends on the objectives, but usually we grow rust nurseries, what we call nurseries, and the entries in a nursery would be, usually they are, if they're just germplasm evaluation, they could be unreplicated. Small row plots from 0.5 meter, even smaller, I guess, to up to 2 meters if you have enough space. Could be single row or double rows as they do it in Joru. And then for the yield trials, you obviously need larger plots. And then if you do mapping populations where you want to determine which genes or how many genes are involved, you should have replicated experiments at different sites, maybe within the same year, and also repeated over seasons. And we've heard this statement, I think, several times. Spreader rows or check rows are extremely important. And again, depending on the size of your experiment, you can decide where to put these and how many of them to put. It was just mentioned at T that a station like Njoro in Kenya, they have 50,000 entries per year. So it'll be very difficult to include a check after every 10th or 20th entry because you will run out of space. So again, depending on your specific situation. I like to plant small blocks of 3 to 5 rows of a susceptible entry, which I call hotspots. I use them for inoculation purposes, and that helps to get the epidemic going if you're in an environment where you don't have a natural epidemic starting very early in the season. And obviously the design of your field plot should give all your entries an equal exposure to your rust inoculum. Your spreaders or checks could also be planted earlier if you would like to have them at a more advanced stage. So when the others mature, that you already have good infection on your spreader lines. And again, I'm sure those of you that work in the field know all these things. General trial management is extremely important because the better the trial, the better the data. If you have lots of weeds or the irrigation system is not working or you have aphids or confounding diseases or soil problems, fertility problems, you won't get good rust data. So you really have to be a good field person to be able to get good rust data in the end. Weather monitoring, it's important if you want to go back and explain certain things over years. How did the weather, maybe the weather influenced my epidemic last year because it was 3 weeks later than usual. It's always good to have the basic weather variables available. Keep record of everything. Record your maturity differences because that'll have an effect on when you inoculate, how often you score, and also when you can harvest.